So this is the first method by which we can just extend the thread class. So you can see that we have created a class over here which is extending the thread class, and we have mentioned that run method over here. Okay, so what we are doing, we are just creating the object of this particular class, and this object will use that start method. So automatically my thread will start in this case. Clear? So you have seen that a simple example, simple statement will be printed over here. That is thread is running. Next is that how we can implement create a thread using a implementing runnable interface. So what we are doing over here, that again we are creating a class that will implement the runnable interface. Now this runnable interface is also inbuilt interface. Okay, so it will again using this run method. Now what is the difference between this particular part, that is of runnable interface, and the previous method? In this case also we are creating the object of this class. Okay, and after that what we are just passing this object as a parameter to this thread class. Why so? Because this particular object is acting as a normal object only, because it is not the part of any thread class over here. So what we do, we will directly create, as we know that thread is a inbuilt class available in Java. We will directly create the object of this particular class, and that is a thread class, and in this particular thread class we will pass this m1 as a parameter. So it will consider my m1 as a thread object. Okay, so finally what we will do, we are just using this t1, that is a thread object, to start that particular thread. So indirectly we are using this m1 object of this particular class. Okay, so that will be used to start that particular thread in this particular method. Okay, so you can see over here that, like, if you are not extending the thread class, your class object will not be treated as a thread object. Now this thing you must be this thing must be clear in your mind, that if you are not extending a thread class, your class object will not be treated as a thread object. So we need to explicitly create a thread class object like this. Okay, so we have explicitly created a thread class object like here. Okay, in the previous example it was not like this. We have directly created the object of this multi class over here. Clear? And this multi class is the thread class, is extending this particular thread class. So whatever, this is your parent class, this is your child class, so it will have the features of its parent class. So that's why this multi class has automatically become a thread class, because it is extending the thread class over here. Clear? So this thing you must have. So we are passing the object of your class that implements the runnable, so that that class run method may execute. So this is the case over here, that we are not directly inheriting that particular thread class. So we need to explicitly define the thread object over here, and we will pass this m1 as a object over here. Clear? So this was all about that how we can create a thread in this particular. Now the second thing is that now we have done two things. Meanwhile we have discussed two things. One is the new state when your thread is being created, and the second one is the runnable state. So runnable state is what? When you are moving from the new state to the this runnable state, and for this particular case you require a start method. So till now we have done this, we have used only two methods over here. One is the start method and another one is the run method. So run method is automatically available either in your interface part like here, or it is a part of your thread class. Clear? So we have directly used this t1 start method just to use that particular, just to move from the new state to the runnable state. Now we require a thread scheduler. Okay, till now now we want to make a thread to be at the running part. So like there could be a case like we require a thread scheduler. Okay, so this scheduler is a part of your JVM that will decide that which thread will run. Okay, so thread, like we have process scheduler. If you remember your operating system part, in that case we have discussed the process scheduler. In this particular portion, we have a thread scheduler that will decide that which thread will run. So there is no guarantee that which runnable thread will be chosen to run by the thread scheduler. But At a time, only one thread will be run in a single process. Either you have a 10 thread, either you have a 2 thread in a single process, but at a time, only single thread will be running. So we require this thread scheduler just to manage all those different threads in your process. Is it clear that why we require, like we have a process scheduling? What is the purpose of a process scheduling? That will tell you that which process will run. Okay, like we, if you remember your process scheduling algorithm in operating system, we have done that. Priority scheduling is there, first come first serve is there. So again over here also we have a thread scheduler. Why we require thread scheduler? Because in a single process we have multiple threads, but at a time only one thread will be executed. So there should be some particular person who manage that which thread will be executed at that particular time, because we cannot allow different thread to execute it simultaneously, consecutively. Okay, so we require a particular thread scheduler that will see that which thread will be scheduled, which thread will be processed at which particular time. So we have a preemptive scheduling and we have a time slicing scheduling. So in preemptive scheduling, if you remember, we have a preemption. Preemption means that can prompt you. So we have to see that any task that is having higher priority. Okay, so when it enters a waiting or a dead states or a higher priority task comes into the existence. So what we require, that highest priority task executes until it enters a waiting or a dead state or a higher priority task comes into the existence. So preemption is what? When you require some higher priority task to execute. Okay, so that higher priority tasks will always be in the execution bar unless and until it may not be required, it may not require some any input output, we can say the resources. Okay, or unless and until it doesn't comes to that dead state or some another higher priority task which has more priority than the existing task. Okay, that comes under the execution of that particular task. Okay, so this is the part of your preemptive scheduling. Similarly, we have a time slicing. So in time slicing, what we do, by that we will give you some predefined slice of time and then re-enters the pool of a ready task. So we, whatever the threads we are having in a particular process, each thread we have a different time slice. We give a different time slice that first 10 minutes are for this particular thread. After 10 minutes, this thread will execute and so on. Okay, so the scheduler then determines that which task should execute next based on the priority or the other purpose. Clear? So similarly, like we have a process scheduler in the case of a process scheduling, in the case of a thread scheduler also, we have a thread scheduling part. So we have, now before that, now for this thread scheduling, what we require now, there is another method, that is a sleep method. So the sleep method of this thread class, if you remember your thread class that we have implemented, so you can see that we have discussed over run method is there, start method is there. Next method that we are going to run is the sleep method. So what this sleep method does that it will execute the currently executing causes the currently executing thread to sleep. For this, temporarily it will prompt your execution for the specified number of milliseconds, for the specified number of the time. Okay, so in which parameter we are mentioning that time, that is under the form of a millisecond. So you can see over here, like why we require this thread sleep method. That will, that is sleep means like we all do this exercise sleep, like we go to sleep at night. Similarly, there is a particular method, sleep method in Java, that prompts a particular thread class to sleep for certain time. Okay, so we have to specify that particular amount of time. So there are two basic methods for the sleeping a thread. Like we have a public static void sleep long milliseconds that will show you interrupted exception. Okay, so we require to check this particular thing under the exception part, because there could be a chance like you have mentioned that particular specified time or in the negative form you are, so there could be chance of an error. That's why we always use this throws interrupted exceptions. So I hope you are clear with this particular term throws. So that will explicitly tell you that some exception is there. And interrupted exception is what? This is an inbuilt exception in Java that will prompt the working of any type of a thread. Okay, interrupted means interrupt, prompting. It is prompting you to do some particular task. So that is interrupted. Similarly, we have a public static void sleep long millisecond comma int nanos. That will also throws interrupted exception. Okay, so as we know that at a time only one thread is executed. So if you sleep a thread for a specified time, so thread scheduler will pick up the another thread. So this is the functioning of this sleep thread method. Why we require this sleep method? Because as you know that we have a multiple threads in a single process, but at a time only single thread will be in the execution time. At a time only single thread will be executed. So sometimes we require some another thread to be executed. Okay, so in that case what we do, we will make a current thread to go to the sleep mode for a specified time. So and meanwhile a thread scheduler will pick some another thread. Clear? So this is the functioning of a sleep method. Now again, this is I just want to discuss this particular parameter, that it will cause the currently executing thread to sleep for a specified number of a milliseconds. Okay, plus the specified number of a nanosecond. So it will define the subject to the precision or the accuracy of the system timers and the schedulers. Okay, so we have a millisecond plus the nanoseconds that will tell us that at which particular time you are using that particular sleep method. Okay. Similarly, we have a nanos over here. So nano is in the this particular range, that is 0 to 6 times 9. Okay. So additional nanoseconds we require. Okay. So like we have a milliseconds, normal seconds are in the millisecond, and plus we have a minimum amount of a time that is in the form of a nanoseconds. Clear? So this method does not return any value, but there could be a chance of an exception. So we need to check that particular exception. Why there is a chance of exception? Sometimes we give that values in the form of a negative, or a value of nano is not in the given range. So that's why we require to check that particular argument over here. Similarly, we have an interrupted exception over here. If any thread is interrupted, the current thread. Okay, so in that case, we require to check that that thread must go from the normal execution to that particular interruption part. So interrupted status of the current thread is cleared when this exception will be thrown. So this was all about that how we can use the sleep method. Okay, so I hope you are clear with this particular term. Now I will use this. I just implement this one of the, we can say that. Okay, so I just you mention you that how we can use the sleep method. So like let's suppose I just create a class over here, and I am mentioning that class as a S1, and that will extend the thread. So this is a simple program that I will tell you that how we can use this sleep method over. So which method we are following? We are using a class that is extending the thread class over here. Okay, so what I will do, I just write the code over here. So my this S1 is a thread class now. Why? So because it is extending the thread class. Now we have a public void run over here. Okay, so this is the one of the method that we use in the thread class. Okay, so this method why we require just to make a thread from the new state to the runnable part. So what we are doing over here, that we need to check for int. I am taking one of the variable as, and I will check that this particular value. Okay, so I am just clear. Mhm. Yes, student, my voice is audible. So you can see over here that what I am doing. मधु मैम मैं चलता ही होएगा ना. Hello Akriti, can you hear me?
Yes, ma'am, now we can hear you.
Okay.
Am I audible, ma'am?
Yeah, you are audible. You tell me you are. You can see my screen.
Ma'am, not the screen sharing, but the Zoom join the. Yes, ma'am, now we can see the screen sharing.
Okay, fine.
Thank you, ma'am.
Okay, students, what we are doing over here that we are just simply there is a class and we are extending that thread class over here. Okay, and there is a run method that we need to define just to use the implementation of that particular thread. Okay, so what we are doing over here that we have used this you can see over here that I have take one of the variable and what I want that my this particular part that is I part. Okay, so this thread must be on go on but with a sleep method. So what I want that at a time one thread will work and after that it will go to that sleep mode. Okay, and it can check for any type of exception if it is there. Okay, so we have just put that particular thing under the this particular cache part in which you can just define that like we are just using this exception part over here just to tell that if there is any exception, it must be cached by this particular block. It must be handled by this particular block. Now you can see that in this public static void part, void main. Okay, so we are having that string. So we just passing that string arguments over here, and now what we do, we will create the object of this particular S1 class. So S1 S equal to, that will be a new S1 dot S equal to new S1. Okay, so I just want to tell you that how we can use all those things. Okay, so we have created one of the this particular class, and again we have uh, 1, and we have another object over here, that is T equal to new S1. So what we have done so far, that we have just created two objects, that is S and T. Okay, so we have just created this two thread object over here. How we came to know that these are thread object? Because this S1 class is extending your thread class. Now you can see that we can start with this particular threads, like S dot, we have start, and we have T dot start. Okay, so this is the main thing that we can discuss. And now see, now these are the two threads. We have created two threads, but how this execution will be there? Like once your one particular thread will be executed, after that it will immediately go to this particular sleep part. Okay, that thread will go to sleep, and meanwhile your another thread will start. So you can see the execution of this particular program. Like we have a, that is S1 dot Java. Okay, so you can just save this particular thing, and I just implement this part. So we have Java C S1 dot Java. Now there is an error, so we can okay. So can just wait for a while. I think some, I think I'm missing some part over here. Okay, the size is not there. We have to just pass this exception. It is E. Now I just run this program. Okay, now this is so you can just see. I think some error is there. So I have already made this particular program. So just show you that particular thing. Like we have a simple, the concept is same that we have simply mentioned over here. That is a run method. So like again, we are using the sleep method just to prompt our current thread. Like we have a T1 and T2 are the two threads over here. So you can simply see over here like when I will run this program is same as that we as I have made currently made, but just it was just a I have discussed this previously also. So you just write like sleep1 dot java. See, so this is how you can see that like this was the case over here where we want to print this particular the value of I. So what is happening over here like your when your T1 will start. Okay, so what will happen when your this T1 will start, it will get executed and your output will be 1 over here. Okay, then after this particular execution it will go to that sleep part. Okay, so you are just making this thread to sleep for a 500 this time span that you have given 500 millisecond, and meanwhile your second thread will start over here, that is this again you are having that value 1. Again your T1 will start, it will the scheduler will move that T1 again into the runnable part. Now your value is 2. Again your T2 will start, now your value is again 2. Okay, so at one time your T1 will be executed, another time your T2 will be executed. Again it will prompt that T1 and it will give you the output for this upper output is for the T1 and the next output is for the T2. Similarly, 3, 3, 4, 4. So this is the case when we can use this particular concept of a sleep. Like we have a multiple threads and we are prompting each thread every time to sleep for a defined time, so that after that it can meanwhile your another thread will be executed. So this is the purpose of this sleep method over here. Now there is a next part that I need to show you. So this S1, the program that I was currently making, so I think some errors are there and it is a quite a little bit error. So I am unable to use it. That's why I'm just executing the already program. The program is same that I have already discussed. Okay. So meanwhile, I can just see that you can just see over here that we have created two threads and we are calling that thread each and every time. Okay, so every time when it will be executed, it will be prompted for a particular time span, and after that your second thread will be executed. Clear? Next is that what will happen now. There is another case that I need to tell you. Now let's suppose we have this particular thread. Okay, now what will happen if I start a particular thread twice? What will happen? Now let's suppose I am using this T1 dot start. So what will happen if you start a thread twice? Now this type of a question can come into your exam. Like you can see over here, th dot java. So you can see Java C. What I want that I need to start this particular thing, th dot java. So what I want to show you that what will happen if you start a particular thread twice. ठीक है, तो क्या होगा हमारे पास, what output you will get? What do you think that what will happen if you start a particular thread twice over here? So you can see over here that if I start my particular thread twice, so it will give you an exception. Okay, so it will give you an exception that you cannot start a particular thread twice. So this type of a question may occur in your exam, that in particular case when you need to see that what will happen. So by mistake also, if you have started a particular thread twice, then what will happen? Now the another case is that now what will happen if I run this particular thread over here. Like we have a uh, we use t1 dot start. So what will happen if I directly run this method? So t1 dot run, this is the case. Okay, because this is also the method, inbuilt method that is available in your thread class. Now what will happen that if I directly use this run method with this particular thread object, now you can see there will be no difference in the execution. But the thing is that now this particular t1 will be will not show you any different call stack. Okay, it will not prepare a different call stack, but it will be working as a normal object only. Okay, so if you are now what I am doing over here, I am directly starting this particular thread. So thread is running, output will be same, but it will not be working as a functioning of a thread because it is acting as a simple thread object. Because in order to start a thread, we require a start method over here. Clear? So same thing you can see in this particular PPT also. Like we have this example. Now what will happen if we start a particular thread twice? So it will give you an exception, that is a illegal thread state exception. Okay, so which will tell you that you can run a thread only once, but for second time it will throw you an exception. Now what if we call run method directly instead of start method? So what will do that it will start invoke the run method from the main thread. Okay, so the run method will go into the current call stack. So it will not go to the beginning of a new call stack, but it will start from the same call stack. So it will not be showing you a particular thread state over here, but it will be acting as a normal thread. normal object. Okay, so as we know that each thread has a separate call stack because we have multiple threads in a single process. So, but if we directly invoke this run method, what will happen? The run method will not go to the will goes to the current call stack. So it will not create a new different call stack for a particular thread. Clear? So this is the difference. Now the next thing is that now same thing you can do with this particular also, like you we have a simple program over here. You can see like this is the run method over here. So what we are doing over here, we have a simple run method and we are just printing that value of that I, and I have created two objects over here, that is T1 and T2. Now what will happen if I directly use this run method? Okay, so what will, as you know that in the previous example where we have used T1 dot start and T2 dot start. So what was happening, that particular context switching was there, but you can see over here that when you will directly use this run method, there is no context switching. So it will be treated as a normal thread object, but not a it will be treated as a normal object, not a thread object. So what will be the output in this case, that it will execute firstly like 1 2 3 4 5, and after that your another object will be executed, that is 1 2 3 4 5. So first five elements are for this T1 object and another five elements are for this T2 object. Okay, so there is no context switching if you are using this run method directly, because in order to use that particular context switching, or in order to manage that thread scheduler portion, you require a particular start method over here, because that start method will create a different call stack. Okay, so it will create a different call stack over here. So that we have already discussed in this part, that as we know that each thread has a separate call stack. In order to use that call stack, we require to use that particular start method, not a run method. Clear? Now the next part is the joining thread. Now this is one of the most important topic. Like we have a joining thread. Like sometimes what will happen, that one thread needs to know what another thread is doing. Either it is alive or not alive. Okay. So there is a condition when we require that a one thread must know that which thread is terminated. So in for that particular part, we have a two methods over here, that is alive and the join. Okay, so we use this two method, that is alive and join. Now also both this method also are the part of your this thread class. If you remember your diagram, this particular thread class, you can see we are now discussing the another part over here, that is a thread class. See, these are the another method, like we have a join, and the another method was the is alive. So this is also one of the method that you can use in your this particular multi-threading part. So you can see over here. So why we require this joining method? Because sometimes one thread is required to know that what other thread is doing. Either it is terminated, either it is alive, or we have to immediately start after the one thread will be executed. So is alive method returns true if the thread upon which it is called is still running. Otherwise, it will return a false statement. So you just remember this time. Is alive matlab it will check that whether the thread is alive or not. So if it will be alive, it will return you a true, and if it is not running, it will return you a false value. Similarly, we have a final. What is the syntax for this? That is final boolean is alive. Why we require this boolean? That is to check that whether that particular method is alive or not. Okay, so the answer will be in the form of a we can say that true or false. So similarly, we have a join method that is more commonly we can use in behalf of that is alive, and this method will wait until the thread on which it is called terminates. So join will, when we use join, that once your thread will be terminated, it will be joined after immediately after that particular thread. So again, we have to check that final void join, and we will show that it will explicitly define you the interrupted exception. So using join method, you can tell a thread to wait until the specified thread completes its execution. So we will discuss both this program with the help of a program. So you can see over here that we have created a class that is alive one. This is my class name. Okay, so that is extending the thread class over here. We have a public void run method. So what is in this run method? I am just want to print a particular, that is R1. Okay, so now once that particular thread will be executed, it will go to the sleep part, and we will go for if there is any exception is there. And after that, either it will run R1, and if there is no exception, it will run the another thread that is R2. Now what we have used, that we have created two objects over here, that is T1 and T2. Now both of these objects are the thread object, because is alive one is the class that is a thread class. Okay, now we what we are doing, we are doing T1 dot start, T2 dot start. So T1 dot is alive, what we are doing, we have started both the threads. Now it will check the whether both the threads are alive or not. So it will work upon like T1 dot is alive and T2 dot is alive. Clear? So we are directly calling this particular thread over here. So it will see that whether that particular thread is alive or not. Okay, so what will be the output in this case, you can see over here, like I am using Java C. Okay, I think you are clear with this particular thing. This portion is similarly same as we have discussed earlier. Okay, so we have just started the thread, and after that we have used this method is alive on both this thread, just to check that whether this thread is alive or not. Okay, so what we are doing over here, so we have is alive one dot Java. ਇਹਦੇ ਉੱਤੇ ਨਾ ਹੱਥ ਰੱਖਿਓ ਫਿਰ ਬੰਦ ਨਾ ਹੋਵੇ Okay, my voice was muted. So I again repeated over here, like you can see like this. Clear. This is the output. Now what is the output? Like your R1 will be finished first. What like I just remove this. We just check it. Like we have Java, C, join. Okay. Now, what is the function of this join method? That what this join wants, that let your T1 to finish first. Okay. Now, how T1 will finish when both of this R1 and R2 will be printed. Okay. So you can see over here when we R1, R2, R1, R2. That means we want the T1 to be completed first. But if we don't use this join method, what will happen? Now you can see over here, if we don't use this join method, like here I just show you, like if I just hide this particular thing, star, and yeah, I am just making this as a command. So okay, so you can go over here. ठीक है, हमने क्या किया? I just remove this particular thing. I am not using this join part over here. I am just starting with t1 dot start and t2 dot start. Clear? So what will happen now? What will be the output in this particular case? See, it will give you output R1, R1, R2, R2 because there is a context switching over here. Okay, so what will happen when you start this T1? It will print you that R1 and after that it will go to the sleep mode. Okay, when it will go to the sleep part, what will happen? Your scheduler will move to the next thread, that is T2, and again your this R1 will be moved. Clear? After that again your R2 will be printed and your R2 will be. But when you use this join portion over here like this, what will happen? It will allow your first thread to complete first. Okay, so that is R1, R2, R1, R2. So this R1, R2 are for the T1 and this R1, R2 is for the T2. So this is the main function of this join method, that it will allow on any thread on which you are making that join part. Okay, you are any thread you are with which you are using this join method, it will allow that it will wait for that particular thread to finish first, then only it will move to the next part. So this was all about that we have discussed so far, that what is a thread is alive, and we have discussed that joining threads, and we have discussed the sleep and the scheduling on. So all these things are the part of your scheduling portion that will tell you to run which thread at which particular time. So I think before moving further, I can just discuss the polls with you. So kindly be ready for that polls part. So I'm sharing with you the very first poll. Okay. So kindly we hurry up for that, and I just discussed two of the polls with you, and after that I will complete the rest of the topic. So I'm going to launch this particular poll.